The National Electrical Code, or NEC, prohibits the practice of connecting two circuits together in parallel except in specific circumstances. NEC Section 210.4 states that circuits shall not be connected in parallel or in series except as specifically permitted in this code. There are a few exceptions listed, such as those provided for in Sections 210.11, 240.21, and 410.14, as well as permitted in Section 695.6e. However, the scenario of running two circuits of the same ampacity to multiple loads and connecting the two circuits together at the end of the run does not fall under any of these exceptions. The primary reasoning behind this prohibition is related to overcurrent protection, voltage drop, reliability, and code compliance. Firstly, overcurrent protection is a critical concern. Connecting two circuits together creates a parallel path for current flow. In the event of a fault, this could allow more current to flow through the conductors than they are rated for. For example, if you have two 50 amp circuits connected in parallel, a fault could potentially draw more than 50 amps through each conductor, exceeding their capacity and potentially causing an electrical fire due to overheating. The overcurrent protective devices, such as circuit breakers, are designed to protect the conductors based on their ampacity. When circuits are connected in parallel without proper engineering and protection, the protective devices may not function as intended, leading to a hazardous situation. Secondly, voltage drop is another important consideration. The parallel path created by connecting the two circuits can increase the voltage drop, reducing the available voltage at the loads. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction, operate inefficiently, or even fail prematurely. When circuits are connected in parallel, the increased current flow can exacerbate voltage drop issues, especially over longer distances. This can lead to performance problems and potentially damage sensitive electronic equipment. Thirdly, reliability is also affected. Having two circuits supplying the same loads increases the risk of an interruption if one circuit fails. While redundancy might seem like a benefit, the interconnected nature of the parallel circuits can create a single point of failure. If one circuit experiences a fault or is disconnected, it could affect the operation of the other circuit and potentially interrupt power to all the connected loads. This can be particularly problematic in critical applications where a continuous power supply is essential. Fourthly, code compliance is paramount. The NEC specifically prohibits parallel connections of circuits except in the specified exceptions. This prohibition is based on years of experience and research, and it is designed to ensure the safety and reliability of electrical systems. Ignoring this requirement can result in code violations, fines, and potential liability in the event of an accident or fire. It is essential to adhere to the NEC guidelines and consult with a qualified electrical professional to ensure that all electrical installations are safe and code compliant. In summary, connecting two circuits together in parallel without proper engineering and protection is generally prohibited by the NEC due to concerns about overcurrent protection, voltage drop, reliability, and code compliance. It is crucial to understand these concerns and follow the NEC guidelines to ensure the safety and reliability of electrical systems. If parallel connections are necessary, they must be implemented in accordance with the specific exceptions outlined in the NEC and with the guidance of a qualified electrical engineer. This will ensure that the conductors are properly protected, voltage drop is minimized, and the overall system is safe and reliable.